I want to talk about combinations and permutations. Both of these things are counting tools that we often use in probability in order to figure out how many outcomes there are possible. Because probability is typically, figure out how many ways you can get what you want divided by how many total ways something could happen. Simple example would be rolling a die and saying, well, what's the probability of getting a 1? Well, there's 1 out of 6 possibilities, so 1/6. So again, combinations, permutations are ways of counting possibilities. And they apply to 2 different types of scenarios. So this first one, 10 students are interested in running for senior class. 3 students can win an office, president, vice president, or treasurer. How many different ways can the students win a position? Well, in this case, we have 10 students that can win that first spot. So I typically think about these like, okay, we've got president, we've got vice president, we've got treasurer. And you say, well, the first spot, if you're just kind of picking, there are 10 people that could win president, and then that person's out. So now you've got 9 people left that could win vice president, and then you've got 8 people left that could win treasurer. And you would just multiply those and say, well, there's 720 different ways for that to happen. This is a permutation, okay? I'm going to put a big P above this for permutation. And a permutation is when you're picking things out of a total group and there's a difference in the positions being filled. Right? In this case, we had a president, we had a vice president, we had a treasurer. Those are different things. So I'm going to make up 3 names. I'm just going to put their initials up here. We're going to have Angela, we're going to have Dave, and we're going to have Lauren. So for example, if Angela were president and Dave were vice president and Lauren were treasurer, that's a very different situation than Lauren being president, Angela being vice president, and Dave being the treasurer, and so on, like that. Those are different outcomes. The order matters. Let's look at the other scenario. 10 students are interested in running for senior class. 3 students are going to be picked to be on the committee that makes up the group. How many ways can the student win a spot? Well, we still have, 10, 9, and 8. But now, like over here, we haven't assigned any kind of like role. We don't have a vice president, a president, or a treasurer. We just have 3 students. So an Angela, Dave, Lauren situation would yield nothing different than a Lauren, Angela, Dave, because in either one of these orders, it's the same 3 students being picked. So what we do in this situation, which is called a combination, is we take our existing multiplication, kind of like permutations, and we say, well, how many different ways are there for just the 3 students we're talking about to be picked? And that is actually a, 3 times 2 times 1. There are 6 ways that Angela, Dave, and Lauren could make up the 3 that are picked. So in this case, we would end up doing 720 divided by 6, which would be 120. So when the order matters, there are more ways to order them, which I hope makes sense because, again, we'd have 6 different ways to order these 3 students. Where over here, all 6 of those ways yield 1 committee. Just those 3 kids got picked. Order didn't matter. So a permutation is any time the order matters, and a combination is when it doesn't. Now, in terms of a formula, what you'll usually see is n factorial, n being the total number. So in this problem, it was 10. Well, it's the same thing over here. We started with that. Then you'll see an n minus r, where r is, so I'm going to put like an n here, r is the number of kids we're picking. Now, the reason we do that, if I could just kind of write this, we'd have 10 factorial, and down here we'd have 10 minus 3, so 7 factorial, is this would basically, the factorial starts us at 10 and it's multiplying down 10 times 9 times 8. But factorial would go all the way down to 1. We don't want to do that. We want to stop at 8. We want to halt the counting. That's what the denominator does. 7 factorial would stop us at 8. So you'll usually see this formula. Now, in this case, it's probably just as easy to do 10 times 9 times 8. But if you said, well, I've got 300 kids and I'm filling 25 positions, well, who wants to multiply that out? 25 numbers. It would be easier to use this formula. So in this combination case, we start off with that same type of thing because we still want to stop our counting. You know, here we only want to assign three things. So this is still our n, and this is still our r, but then we also divide by r factorial right here to symbolize that those 3 kids being picked, well, the order didn't matter because anyway, those 3 picked, we count as one committee. So this is the permutation formula, and this is the combination formula. I want to also show you how to do this on the calculator. All right, so this is should look like a TI-83 or 84. Okay, you are going to press the math button and go over to PROB for probability and choose NPR for permutation. And then you just fill in these little subscripts, 10 and 3. And there's my 720. We go back to the math button, over to probability, and choose NCR for combination. Fill them in, 10 and 3. And there's our 120. This is actually also the way we often write our problems as shorthand to designate we knew it was a permutation or a combination. Let's do a couple more examples. Frank has 10 shirts. On Sunday, he decides to pick out a shirt for each day of the week, Monday through Friday. How many different orders of shirts can he pick out? Well, in this case, okay, he's picking a different shirt for Monday, for Tuesday, for Wednesday, for Thursday, for Friday. So he's got 10 shirts, and he's picking for 5 days. So 10 is our N, 5 is our R, and in this case, picking a shirt for Monday, Tuesday is different. Those are different days. So we would say this is a permutation. And we'd say it's 10, 5. And you could, again, just use your calculator to figure out what that is. If you were just using factorial, you'd do 10 factorial over 10 minus 5 factorial. All right, Nora has 6 pairs of shorts. She's going on a 4-day trip to a tropical island paradise. How many different combinations of shorts can she pack? Well, here we haven't been told, that she's wearing them on certain days. It's just, okay, she's got 6 pairs. She's picking 4 to throw in her suitcase. So now this is a combination. So this, we had 6 as our N. We're picking 4. So that's our R. So we say this is a combination of 6 choosing 4. I would use my calculator for this part, but if you wanted to use the formula, you do 6 factorial over 6 minus 4 factorial, and then 4 factorial. All right, Corinne is on the swim team with 20 other people. The coach is going to randomly pick the 4 students that will swim the medley relay. First person picks swims backstroke, second swims breaststroke, third butterfly, fourth freestyle. So in this case, it makes a difference which order you're picked because the first person swims a different stroke than the second person. So this would be a permutation. 20, picking 4. If you wanted to use the formula, you'd say 20 factorial and 20 minus 4 factorial. Again, I just want to point out that what this would yield is just saying, well, 20 times 19 times 18 times 17. It's just the 4 people picked for the strokes. That denominator is just what cuts us off 4 numbers down. Jen is planning a family reunion and assigns herself the task of bringing dessert. She has 10 recipes she could make. She decides that would be too much. She's going to only bring 5 desserts. How many different ways could that happen? Well, in this case, of course, we don't really care what order. There's nothing special about the first dessert. So we would just say, well, this is a combination of 10, choosing the 5. And again, if you wanted to use the formula, it'd say, all right, the total, then 10 minus what we're picking, and then 5 factorial.